Eagle's regression test for assessing a publication bias from data or result extracted from several independent publications to perform meta-analysis. So meta-analysis is a statistical method that combines data from several independent research studies that addressing specific clinical or medical or research question. Those pooled data are analyzed through meta-analysis to produce an overall effect size estimate from those separate studies. If you find this video useful, do subscribe to the channel and hit the notification bell to receive an update of new releases of videos onto the channel, and also press on the like icon and share the link for the channel so that the channel will develop to include a wide scope of statistical analysis methods in different packages such as the SPSS, Excel, Stata, Jamovi, R Statistics, GovPad, Prism, Python, SAS, and RevMan. So what is a publication bias? A publication bias occurs when studies with significant outcome or significant results are published, preferably, and released into different journals, and those that they have no significant results are less likely to be published. So there is a bias or shift toward publishing result or data that show or shows positive or statistically significant association or effect relative to the studies that have no statistical significance or are negative. So this is the concept of publication bias. So selection of significant result and deselection of non-significant results will lead eventually to overestimation of the calculated overall effect size when performing meta-analysis. So this will deviate from the true effect size. The most common method that are in practice and used to assess publication bias when performing meta-analysis on a collection of data extracted from several studies to calculate the overall or pooled effect size are: the first one is the funnel plot. Well, funnel plot is a scatter plot that will allow visual examination of the distribution of the estimate of the effect size. A second method, which is statistical, based on statistical analysis, such as the Eagle's regression test, the Begg and Mazumdar's rank correlation test, and the trim and fill method. So to check and examine and assess whether there is a publication bias, funnel plot can be produced post meta-analysis, and the funnel plot as shown here is a scatter plot with the y-axis plotted in it a standard error or a sample size, and on the x-axis is the estimate of the effect size when the outcome or the data are continuous, then standardized mean difference can be used. One of these are the Cohen's d, or the Hedges g, or the Glace's delta. If the outcome is binary, then the estimate of the effect size can be the odds ratio, or the risk ratio, or the hazard ratio, or even it can be a proportion. The shape of the plot as shown here is in a shape of a funnel, inverted funnel, and the line in the middle here is the calculated overall estimate of the effect size for, here in this case, is the Cohen's d, and the small blue circles are the estimate of the effect size for each individual studies. So here there is 5 and 10 studies in total included in the meta-analysis. And from this funnel plot, it is possible to visually determine whether there is a publication bias by counting the number of estimate effect size that are found in this section, and the number of the effect size in the other section. So this line will split the funnel into two halves, and for lack of bias in publication, the distribution of the estimate of the effect size should be equal on both sections, for which means symmetrical distribution. For publication bias, there will be asymmetrical distribution of the data. So this is one of the steps that can be performed to check whether there is a publication bias. But this is not enough, as it is based on visual inspection and personal judgment. Another test that need to be done, statistical test that will back up or validate the outcome from the funnel plot, which is the Eagle's regression test. So this test is called Eagle's regression asymmetry test because it check for whether, or it tests for asymmetry in the funnel plot. So it is a statistical method that is used in meta-analysis to assess for publication bias. It examines the relationship between the standardized effect size estimate, which could be the odds ratio, the risk ratio, or the SMD, based on the type of an outcome, whether it is a binary or it is a continuous. So the estimate of the studies included in the meta-analysis and their precision, and the precision is the inverse of the standard error. So it is based on linear regression method, and that aims to fit a regression line to the data point on the funnel plot. Since the funnel plot is a scatter plot, then a regression line can be fitted into the dots on the plot to generate a regression model. So the Eagle's regression test is also called Eagle's intercept method because it provides a test for the intercept of the regression line. So if the intercept of the regression line is examined and determined to see whether it is significantly different from zero. Aims of Eagle's regression test is to assess and test whether the intercept of the regression line is statistically different from zero. So statistically significant intercept suggests the presence of publication bias. The value of the intercept also is important, as if it is not close to 0 or not equal to 0, then this suggests the presence of publication bias. And for lack of publication bias, the intercept values should be as close as possible to 0 or equal to 0, with a p-value greater than 0.05, which is not significant. To perform the Eagle's regression test, the null hypothesis has to be generated an alternative hypothesis. So the null hypothesis states that there is no publication bias, i.e. the intercept is equal to 0. The alternative hypothesis states that there is a publication bias and the intercept is not equal to 0, and then this is backed up by the p-value, statistical calculated p-value, which could be less than 0.05 or greater than 0.05. For no publication bias, the p-value need to be above the 0.05. So I had here inserted a output of Eagle's regression test for a data or an outcome that is continuous and based on SMD effect size, and as shown from the table here as circles, the intercept value is 0.25 and the p-value is greater than 0.05. Another method other than linear regression tests such as Eagle's regression, that method is based on the rank correlation test. It's called Begg and Mazumdar's rank correlation test. It assesses if there is a significant correlation, again, between the ranks of the effect size and the ranks of their variances. This method is based on the Kendall tau correlation coefficient, and it measures the association between two variables. If you have a data, or if you need a training course in using any of the statistical packages listed here, or any other packages, then do contact me to arrange for one-to-one lessons, private lessons, and design training courses to fit your requirements.